Have you ever wondered what the weight of a neutron star actually is? Imagine a star so heavy that a single teaspoon of its matter would weigh more than 10 billion elephants. When a massive star collapses at the end of its life, it forms an incredibly dense object called a neutron star. These stars are just a few miles wide, but can have a mass greater than our Sun. The reason why they are so dense is because all the matter in a neutron star is packed together extremely tightly. This is why a neutron star is so dense. Its mass is spread out over a much smaller volume than before. But this also raises another question. How does the density of a neutron star compare to the density of other objects? As a neutron star rotates, its magnetic fields sweep across the universe like a lighthouse beam. This creates a periodic signal that can be detected by radio telescopes. We hope that you learned something new and that you are as excited as we are about the mysteries of the universe. If you want to learn more about space, check out our other videos. And be sure to subscribe to our channel so that you never miss an exciting new video. Until next time, keep looking up. In fact, the first neutron star ever discovered was found by radio astronomers who were searching for pulsars. Let's take a look at the following table, which lists the densities of several objects from the lightest to the densest. As you can see, a neutron star is one of the densest objects known to exist in the universe. Only a few other exotic objects such as black holes and quark stars are denser than a neutron star. In fact, a teaspoon of neutron star material would weigh about 10 billion pounds, which is the equivalent of 100 times the mass of the Empire State Building. One way that astronomers have detected neutron stars is by observing their X-ray emissions. When a neutron star is formed, it can have a very hot surface temperature of up to 1 million degrees Celsius. By studying these strange and fascinating objects, we can learn more about the fundamental nature of matter and the extreme conditions that exist in the universe. This temperature quickly cools down to around 1000 degrees Celsius. However, the neutron star still emits X-rays due to the intense magnetic fields around its poles. These X-rays can be detected by instruments on Earth and in space, providing evidence for the existence of neutron stars, the incredible weight of neutron stars, and what makes them so dense. First, let's understand what a neutron star is. It turns out that the mass of the star is conserved during this process. This means that the total mass of the neutron star is equal to the mass of the original star. However, the distribution of that mass changes dramatically. To understand this, let's think about what happens to the volume of a star when it collapses. As the star collapses, its volume decreases by a factor of 1 billion. This means that the matter in the star is being squeezed together extremely tightly. For example, if a star has a radius of 10 kilometers, its new radius after collapsing would be only 10 millimeters. That's a decrease in volume of about 1 billion. But how does a star collapse in on itself? When a massive star runs out of fuel, it can no longer produce the energy needed to support itself against the force of gravity. As a result, the star's core begins to collapse. This process can be very slow, taking thousands or even millions of years. But eventually the core reaches a point where it is so dense that it collapses in on itself very rapidly. This rapid collapse causes the outer layers of the star to be thrown off, creating a supernova explosion. If you want to learn more about this process, check out our video on the life cycle of a star. Now let's get back to our original question. What happens to the mass of a star when it becomes a neutron star? So if the mass of the star is conserved but its volume decreases by a factor of 1 billion, then the density of the star must increase by a factor of 1 billion. Now that we know how dense a neutron star is, let's take a look at some of the evidence that we have for their existence. Another way that astronomers have detected neutron stars is by observing the signals they emit. Today, astronomers continue to study neutron stars using a variety of techniques. Thank you for joining us today as we explored the incredible weight of a neutron star.